Good morning, everyone. Uh, Today we can discuss one of the key area and as well as the performance and some other kind of a important topic for the DB team and not only DB team. Uh, uh, it's kind of like a all the kind of it's a application server or maybe database server, any server. Okay, if you want to get a good performance, uh, like if you stuck any kind of a pressure on the resource like and that scenario how can you start to troubleshoot those scenario we can discuss. uh, we can record the session and we can send it to our folks as well, maybe they can watch later. But once this topic is completed, you may ask a few questions, I can clarify it itself. Why? Because these are the very important topic for day-to-day activities and as well as the performance P metrics. Those are like a 1 minute. CPU, high memory, slow running. Okay. Today we will try to cover high CPU. If time allows, then we'll go for high memory and slow running. But the thing is like here, high CPU, high memory, slow running course. It's involve the kind of our last. What are the topics we covered from day one to till now? All the topics we must know how to uh, check and where we need to go and to troubleshoot. So kind of like a the resource crunch. Not only we cannot pinpoint because of this one, it is having issue. So that is the reason we need to know all the areas in the SQL server. Then only we can able to resolve the iCPU, iMemory, and slow running. So that means like we need to understand uh, what are the backups and those backups can we take in the business hours or not. Okay. And what are the restoration, do you restore the production server in the business hours or not. Okay. And what are the index rebuild and reorganize. Okay. So if the index fragmentation is more, uh, then what will happen? And do we need to rebuild or reorganize the index in the business hours or not? And we need to understand the what is the blockings. If the blocking comes, what will happen? So blocking also we need to understand. And the most important thing is like we need to understand the activity monitor or to get the some metrics. Okay. So that means like we need to clear understand about the activity monitor. And also we need to understand the one more area called like a performance dashboard. So using the performance dashboard, we can get some metrics for the current server activities. And also we need to know how to run the profiler. Okay. So profiler that will is a come to the next part, like to capture the high CPU or high memory or slow running based upon the some threshold for investigation or checking the what are the consuming those. So what I meant to see here, like if you get any resource crunch, so directly we cannot pinpoint all the areas, but we need to go for uh, all the areas. Why? Because why I'm telling here, backups are restore. Initially, the thing is like some of the DBA folks our team, what they will do, they will run the backups in the business hours. If you run the backups or restore in the business hours, what will happen? Knowingly, unknowingly, that will uh, adding the resource utilization on the DB servers. If the database size is like a small, like below 10 GB, 20 GB or 50 GB, that is okay. That is a day-to-day activities we can perform. But if the database is more than 100 GB or above, then definitely it will put the pressure on the disk and CPU and memory areas. So that is a reason as a DBA uh, L1 or L like L whatever it may be. We should not perform the backups and restoration in the business hours in the production environment. That is a keep in mind that because uh, unknowingly we are giving the problem to the our database server itself. So don't take any backups or restoration on production environment. Okay, in business hours. So here log backup as per the schedule, log backups will run, but you should not initiate full backup or differential backup on the business hours. That is a one thing. And don't run checkdb or index variable or reorganize operations on business hours business hours on production environment. Okay, why? Because if you run the checkdb or reorganizations, rebuild organizations, knowingly what will happen, that will give the lockings and blockings on the server. Then while running these operations, as well as it will take a disk utilization and log utilization on the SQL server, that will have the all the resource utilization. So the resource utilization means nothing but the cores and the RAM and as well as the disk IOs. So before going for actual ICPU pressure, just I'm giving the heads up. What are the things we should not do in the business hours? Then we can go for the actual topic. If you get a real CPU pressure, how can you resolve? So as I mentioned here, backups restoration we should not do on production environment in business hours. Generally, this will initiate from the DB team, so we should not do. And also, don't run checkdb, index rebuild, or reorganization operation on the business hours on the production environment. And other thing is like don't run any bigger select statements or reports on production environment, production production environment in business hours. Why? Because BSSA. Why? Because here the thing is like generally application team what they will tell. I need some investigation purpose. So I don't want to do any update in statement, but I need some select statement. Can I get the? Can you run the this select statement? Okay. So that time what we can do as a DBA team, it's a select statement. There is no harm to affect the production environment. We can think like we can run the select statement. But the thing is like what are the select statement if they're giving that is going for entire kind of a star. If you see like a star from, then we should not run that statement. Why? Because that will pull the lot of data to the uh, load on the CPU under disk pressure. That will give the uh, server hang. So always avoid the star kind of a select statement. So we should not run kind of a star that too based upon the table size and other joint information. If they really want, then we can tell we can run on the non-business hours. But the thing is like we want to know kind of like some information. If they go for any star, like how many records it's going to fetch. So what we can do, we can see like a count, select a count star from table, how many records we have. Okay. Do generally if they ask run the select statement, maybe we need to run and we need to put into the Excel or maybe some kind of a what I meant to say. That inside select statement, they want to go for insert and update statements. So that is the reason we should not run any not only select a statement, we should not run any update, update or any modifications scripts on the business business hours. Why? Because if you run the update or modifications or any bulk instance operations, definitely that will give the while executing, it may take longer time, but that time if you have a, that is giving any locking or blocking, and then because of this script, other statement will go for a hold. That will give the load on the our server. So that is the reason update modification scripts we should not run on the business hours. So generally these things will knowingly or unknowingly our DB team will help to add on the CPU or resource pressure on the business hours. This is the generally will avoid, but sometimes eh, in the maybe some urgent tasks, some other things, we will run it. That is okay. So now we'll go for the actual our CPU topic. So like the thing is like all CPU, memory, and disk utilization will monitoring from the our monitoring team uh, by any alerting system. Okay, that may be SCOM, or that may be IDERA, that may be like an ag use, that may be like some other monitoring tool. So in the monitoring tool, what they will do, they will keep the some threshold. Suppose like the threshold generally what we will do, 80 above we can keep. If 80 is if the resource utilization, okay, 80 percentage, if we can like a warning, okay, and if the utilization is 90 percentage above, we can critical like a critical. And the thing is like 80 percentage and 90 percentage, if the resource is staying more than 5 minutes, then we'll get a alert. 80 percentage or 90 percentage threshold. Okay, so once a alert monitoring from the monitoring team, the alerts will comes to the DBA team or maybe infra team. So based upon the organizations, based upon the roles and responsibilities, the this alerts will redirect to the respective team. Okay, so if you see 80% warning and 90% critical, alert got a CPU on the ESQL server. Okay, so here this kind of like a two troubleshoot we will go. Okay, one is current 90% CPU or everyday 90% CPU on the particular timings. So today topic what we can do, current system 90% CPU and everyday some time range CPU is high. Okay, so here two scenarios we can discuss. Current system 90% CPU, we got a alert. The alert will go to maybe infra team or maybe it will come to the our DB team. Suppose if the current system 90 plus or 90 above, then what will happen? Definitely that will affect the business on the production system. Why? Because if the system is having resource crunch, the system is struggling to handle the load. So that means our CPU is 90% 5 or 90 above, then definitely what will happen? The day-to-day operations. So every day the query will run 2 seconds, 3 seconds. Then if you having CPU pressure 95 or 90 above, that time what will happen? The queries will take a longer time to execute. So the definitely the users will complain and as well as application will respond in the front end instead of getting the results that will take longer time. So that scenario, how can you start troubleshooting and how can you resolve it? So as I mentioned, if you get a CPU 90% alert, then what we can do? We need to log into the that particular computer. Okay, we need to log into that particular virtual machine to check that is CPU utilization by from the SQL server or maybe any other operations. So why? Because sometimes the thing is like most of the uh, environment for critical servers, they won't give the RDP access. What I mean to say, they won't give the system uh, uh, direct login, or maybe we cannot log into the RDP, but we can access from the remote connection. But remote connection, if you have, then troubleshoot is little bit difficult. Why? Because we can will come to know further troubleshoot. So the thing is like if you get a CPU 100% on the alert, then what we can do? We can log into the our SQL server. Like SQL server means like we need to log into the our database VM. So the thing is like we need to uh, get into the virtual machine physically. So that means we are able to see the disk, and we are able to see the task manager, and we can able to see the other kind of like this kind of a environment that is called like a physically login. Okay, physically log into the our virtual machine. The first step is go to the task manager. So here, if you CPU related things, we can rely and we can trust the our task manager. But if it is memory, then we cannot trust the task manager. So here the thing is like our system is 90% CPU high, then first we can trust and we can check the our task manager. So what we can do, we log into the our system as a physically. Then before connecting to the SQL server, uh, then what we can do, open the task manager. Once we open the task manager, come on, 1 minute. See, once you open the task manager, the thing is like here, we can see the CPU. So here, what we can do, you can double click. If you double click in the top, what it will provide, what are the CPU consuming in the that will present in the top. So if you see here, the thing is like in my laptop, up, I have installed the SQL server, I have installed the Zoom, and I have opened the what I meant to say, other applications. So here I have also SQL server. So the thing is like what I mentioned, we need to trust the our task manager that will give the some accurate, that will tell which application is taking CPU. Okay. So if you see here, our SQL server is taking more CPU, then we need to go for further investigation and troubleshoot. But here the thing is like if you log into the our environment, the SQL is using 50 to 60, then that is okay. But other than our SQL service, other processes are taking more CPU. That means we have to inform the Windows team and respective team. Why? Because apart from SQL server, other resources are taking more utilization. So SQL server taking 50 to 60, that is normal. Okay. Because it's kind of like a medium or moderate, our system is healthy. Because if you're running the query, that will take definitely CPU 50 to 60, that is as expected. But the thing is like apart from SQL server, if any other resource are taking more CPU, then we need to based upon the here we can identify and we have to inform the team because of this one is taking more CPU. Generally, the thing is like if we install the antivirus while doing the antivirus scanning, that will take more CPU. So maybe that antivirus are taking a longer time because of the outdated updates or maybe any some other things. That is a kind of a Windows team investigation. So as I mentioned here, apart from SQL server, other is exe process taking, then we have to inform the respective team. So now the thing is like we log into the virtual machine, and what we observed here, our SQL server seeing the more CPU. So here Uh, if you observe, you can see there are 2, 3 SQL servers are coming and going. So in the virtual machine, if we install the one SQL server, then we can easily identify uh, that SQL server is taking more CPU. But the thing is like if you install the 2, 3 SQL server, okay, 2, 3 SQL servers install on the virtual machine, that scenario, which SQL server is taking more ICPU. So from the 2016 operating system, our job is very easy to identify the which SQL server taking we can identify. Why? Because if you go for in the past 2008 or to 2005 operating system, that time very difficult to identify the which SQL process is taking more kind of a CPU. So for that, we used to use process identifier from the configuration manager. If you open the, just let me give, then we'll go for configuration manager. So in the every SQL server having the one process ID. Okay. So here I'm telling like it's a legacy operating system. Okay. So it's a the task manager. We cannot like it's very difficult to which process is taking more CPU. So that time what you used to do like we'll come to the configuration manager. We'll get the process ID, and in the task manager we will add the one more uh, icon as a process ID. From the using the process ID, we'll identify this is the SQL server taking more CPU. But nowadays, like all environment we are using from the SQL server, like operating system 2016. So that is the reason we can easily identify which SQL server is taking more CPU. So here the thing is like if you go here, come on, it's not stabilized anyway. So yeah. So if you see the thing is like if we install the multiple SQL server, then what we can do here we identify the CPU is taking more. Then what we can do, come to the this plus mark, then we have to click it so that it will provide the which SQL server taking more CPU. Here the thing is like see here mine is like a lab and first it is showing. So here the thing is like we identified the this is the my lab instance taking more CPU. So then we need to connect to the that particular SQL instance. So in the my computer having 3 SQL servers. How many I have? Yeah. So in my environment, I am having 3 SQL server in the one computer default instance, lab and first and prod. One, two, three, four. So in that four, how can you know which SQL server is taking more CPU based upon the task manager? In the task manager, we can click it here, the plus mark. In that we can see the our SQL instance. So just now we'll come to know because of this SQL server taking like getting the iCPU on this particular computer. So now from here our DBA investigation it will start. So the thing is like to finalizing the bad queries, to finalizing the investigation because of this queries, iCPU is high. So for that, the thing is like what you need to do. As I mentioned, we can find the what I mean to say iCPU, but once you log into the environment, just what you can do, uh, check the any blockings is there or not. Okay. So because if you have any locks or blockings, that definitely is SQL server will go for iCPU. So generally what we can do, the blockings we can check in the middle of the investigation. But here what I'm telling, just go and check in the first step. So the investigation is kind of a not only pin like thumb rule. We have to check this queries first, and we have to check those queries first. There is no order to check, but from my perspective, what I meant to say, just check the blockings is there or not in the our environment. This is not this is process where blocked not equal to 0 and SPID get to the equal to get to 15. Why? Because uh, if you run this command in the single shot, we can identify the bad queries and locking on the system. We can resolve the things. If the system resources are locked, then definitely it will add on help the CPU and other kind of things. So just run it the uh, long run like blocks is there or not. Okay, just run it. If you have any blockings, and we first the thing is like we can terminate the blockings, or maybe we can go for the in like communication. In the past what we discussed, if you see any blockings, how can we resolve it? So that time what I mentioned, collect the which query is blocked and which query is blocking, and what is the query is running, and which system it is coming, and from how long it is running. Those information, collect it and send the communication to the application team and kill it. So here, if we have any blockings, then immediately we can inform them and we can tell because of this lockings, we are observing some CPU spikes. But the thing is like here, lockings are coming and going. That is not staying longer time. So the thing is like there would be some bulk operations, or maybe there could be long running queries running. Because of that, we are seeing lockings. So in the production environment, the lockings or blockings are common. But the thing is like the locks or blocks, the like a very minimal with kind of a fraction of say, like a milliseconds. Why? Because if you want to get the consistency accuracy data, that means the blockings and lockings are as expected. But the thing is like if the lockings or blockings are more, then that is the kind of a performance and worst cases that will add the CPU. So if the blockings are coming and going, that means our system is giving accurate and consistency data. But if you see that is like a more logs and blockings, then definitely there could be something as a long running queries. So now the thing is like now we need to group all together our past uh, uh, topics, and we need to put into here. So what I mean to say here, the blockings we discussed in the past. So we need to understand the blockings, what is the blocking and what is the header blocker, how to find out the header blocker, and those information. If you're not about the blockings, then it's very difficult to find out and fixing the ICP and application down as well. So that is the reason we need to clear understand of the blockings. The other thing is like now what I meant to say, uh, we discussed one kind of a tool, right? SP who is active. So SP who is active, it is a free kind of a community providing the script. That thing we need to run it. If you don't have in your environment, you can recommend it. You can download the SP who is active stored procedure, and you can keep it into the master database. Or always you can recommend it to the your environment. You can create a one database called like a as per your company standards. That thing we can keep all the our stored procedure on that particular database. So if you don't have anything, you can recommend it to the your team, and you can register the all the stored procedure that that particular database. Why? Because if you get any performance issues, no need to look for the queries or no need to look for other things. All the repository will be available in the one database. So what you can do, you can collect all the what are the queries are useful. You can register those queries in the one database. So here, what I did, like I have a database called like a DBA tools or DBA DB or some other things. So here I already registered the SP who is active. So who is active? If you see any CPU, generally what I used to do, like I will check the sys process and blocking. So this sys process and blocking, I will get it from the who is active. So the now the step got changed. So instead of checking the blockings, now what I'm going to do, I will check the who is active. SP underscore. I don't have. Maybe I have. Yeah. Yeah. So if you remember last class discussions, so this SP who is active very helpful to finding the long running queries, to finding the ICPU, to finding the like disk issues and read things, right? So if you see any ICPU, what we can do, I'm talking about the current ICPU investigation, not for the past. Okay, so the thing is like if you get the ICPU alert and we log into the our computer and we check the task manager. In the task manager we identified that num uh, out of 53 SQL server, one SQL instance is the culprit for the ICPU. So for that, you can we log into the our SQL server. Then what we can do, we can run the SP who is active. So using SP who is active, what we can do, that will provide the queries which are running longer and as well as the any blockings is there or not. So here the thing is like here we covered long running queries and blockings. So the thing is like if the sessions are running as a longer, then by looking at the long running time and column, we cannot define this is the culprit query for ICPU. Why? Because if I going for a walk, okay, that means like I'm not much a CPU consumer. But if I'm going for a like a bike, that will reach 1 or 2 seconds to the destination. But that what I meant to say, if you go for real time, I'm telling, if the query is running like 5 minutes, that may not for the CPU pressure query. But if the query is running 1 minute or 2 minutes, that may be for the CPU intensive query. So that is the reason if you see any performance CPU things like first we need to collect the all the metrics that we can decide this is the because of the queries CPU are high. So as I mentioned, run the SP who is active. In the SP who is active, it will provide the what are the sessions are currently running and how long it is running and is there any blockings there or not, it will provide. So let keep it there. So 80 to 60%, like 60 to 80%, if the queries are running longer, that maybe will add the iCPU. And if you see any blockings, that will also kind of a iCPU on the system. So this is the one part we need to collect. The other thing is like what I mentioned, open the activity monitor, open the activity monitor. If you observed in the like discussions in the activity monitor, active expensive queries. So active expensive queries means currently what are the queries are taking more resource. So from the activity monitor, 70 to 80 percentage will get the CPU consuming queries. Why? Because active expensive queries, and if you go for SP who is active, then we'll come to another some matching sessions or some resource queries will get it. Why? Because here I have a 40 rows there is there. But if you go for activity monitor, I can see only 6 to 7 sessions are there. So that means this active 6 session cores are presented in the my system. So that means out of 20, 6 are high kind of a bad cores. Because of that bad expense cores, CPU is high. So SPU is active, and as well as the activity monitor will get the 60 to 70 percentage of the CPU expensive cores. So this is the one thing. And one more thing is like, if you go for last time we discussed, right, performance dashboard. So the performance dashboard that will provide the last 15 minutes iCPU queries. So if you go for reports, performance dashboard. So if you open the performance dashboard, in the performance dashboard that will provide the last 15 minutes, what are our system, how much CPU is consumed, and which cores are taking more CPU. So activity monitor and as well as the performance dashboard and who is active, we will come to know because of these cores are CPUs consuming more high. So once we get the information, then if the system is going to down, okay, the system is going to down, that means like a application is completely down and the service not responding. The thing is like, just arrange a call with the respective team and you can terminate the session which we are seeing. The thing is like, before terminating all the queries, we need to make sure we need to collect the information. Why? Because after terminating, the application team will ask, can we get the query which you terminated? Because this query may occur in the future and it will go for iCPU resource utilization. So that is the reason, if you want to decide to terminate the session, we need to make sure you need to collect the all the query information, like what is the query and which user is running and which host it is coming. So those information we need to collect and we need to send it. The thing is like here, uh, uh, and sometimes what they will application team will ask, okay, this queries is identified. Can you let me know why these queries are taking more CPU? What they will tell, these queries are a regular queries, every day it will run, but why right now these queries are taking high CPU right now? They will ask. The thing is like, finding the queries and investigation is the things, and resolving the iCPU like a kind of a phase by phase. The thing is like, we need to identify the queries which are culprit, and once we get the confirmation, terminate. Before terminate, uh, you can collect the information, and you can uh, inform the team, like after terminating the things, you can uh, inform the team CP is down. But the thing is like, from now our actual also DB team will work start. The thing is like, as I mentioned, here we see like a locking. Because of the locking session, uh, the CPU high. So why the lock was happen and why the query is taking longer? So the thing is like, my query is supposed to execute 1 minute, but that is taking 5 minutes. So because of the 5 minutes, other worker threads and the other sessions are going for lock. So the first thing is like, why the blocking is happened here. So that means we need to check the query why is taking longer. So if the query is taking longer, then we need to check what are the tables involving that particular. Uh, let me go for troubleshoot. Uh, what I mean to say, next another 5 to 10 minutes. Let me go for another DMVs which is available to find out the logging, like iCPU. So here the thing is like, but the thing is like, now CPU, when the our we got a alert iCPU 90%. Okay, then when you log into the RDP machine, like the alert came 5 minutes back, and the application team are informed to us. We got ICP alert. So Logging into the RDP, it will take 5 minutes. So total 5 minutes. Then once you log into the server, the CPU comes down as a normal. The CPU comes down as a normal. So when you log into the database virtual machine, if you go to the task scheduler, my CPU comes normal. So that means we don't have idea what are the queries or which process is taking more CPU. So for that, it's very difficult to find out uh, which queries ran in the past. The thing is like the one thing is like we can get the catchy queries from the activity monitor and the performance dashboard. So the performance dashboard, it will provide last 15 minutes data for the CPU queries. So from the performance dashboard, we'll get the last what are the queries ran in the 15 minutes. Because of those queries, it may uh, CPU went too high. And the thing is like if you go for activity monitor, that will also provide from the last expensive queries and as well as recent expensive queries. So here recent expensive queries. So active expensive queries will gone, but those query will stay in the RAM. So those will get it from the recent expensive queries. That is from the last 10 to 15 minutes based upon the RAM will get from the queries which we ran. So apart from that, I have one more query I will provide in the chat. You can use it for the last 10 minutes or 15 minutes. The CPU is high. This for disk. Yeah. So this query it will pull from the last la, what is this one? This query will use from the ring buffers from the our DME like a exe underscore request. It's kind of like a combination of the requests and connections and sessions and some other thing. This kind of a bigger query, but I will provide you. You can use this query that will provide the last 10 minutes our CPU uh, more than 85 percentage. Okay, those it will provide. If the system having 85 percentage, these things it will provide. Let me give you. So this query also will help if you having the CPU pressure, then these queries will directly pinpoint and provide the queries which are culprit. So if you committed successfully means there is no queries are currently running and those queries are not a iCPU utilization. But if you having iCPU is above 80 to 90, what you can do, you can run this query. I will ping in the chat. Okay. I will send the WhatsApp. Okay. This much query is not taking. So you can use this query and it will directly pinpoint to the which are uh, taking CPU and also it will provide the percentage of the query CPU taking. Okay. So this will also help SP who is active and this also it will tell iCPU and this query it will provide the last 10 minutes. Why? Because when you log into the server, the CPU is down like normal, but last 10 minutes CPU is high, right? So if you use this query, we can get the last 10 minutes CPU utilization query. So now the thing is like if you go for Microsoft documentation, what they're telling, as per the Microsoft documentation, if you having any iCPU, they have like what I mentioned, the troubleshoot CPU percent to percentage the people, the query syntax will change, but main core content of the queries will be same. So if we go here, what they're telling, identify the CPU queries from the see, as I mentioned here, verify the SQL server from the task manager, which SQL server is taking more CPU. We identified. Then, if it is SQL server, we need to troubleshoot. If there any other process, we need to inform them. The second thing is like what they're mentioning, to get the DMV. So our DMV is like a sys.dm underscore execute on those stats. So that will provide the stats means like a the query which are taking more workers and more time on the server. So this will also will help to identify the current CPU consume system. I will ping you in the chat. You can use it. So if you currently my system having struggling as a CPU 80 to 90 percentage, at that time I need to identify top 10 CPU total worker. That means how long it is taking and how many times the query is executed and what are the CPU average. So if you run it, it will provide the how many times the query is executed and what is the plan handle. So the thing is like here we are not getting the session ID and we are not getting the query. But thing is like it is providing the what are the culprit queries. Okay. But by looking at the report, we cannot determine and we cannot identify which queries are taking more CPU. So that is the reason always go for SP who's active or uh, activity monitor or one what I mean to say. Uh, Yeah, SP who is active and activity monitor that will provide the session ID, some other information. So in the parallelly, just run this command. It will provide the thing is like the query, how many times it is executing and how much time it is taken, and it will provide the plan handle. Using the plan handle, we'll get the query information. The thing is like how to get the plan handle. Yeah. So the thing is like using the query plan, we can get the query which is running here. So here I got a plan handle from the my top 10 worker time or execution count query. I got a plan handle. So this will always help. Okay. Why? Because sometimes I need to flush the query from the query plan. That time we can flush the query plan as well from the buffer cache. So here I taken the plan handle. Using the plan handle, I'm putting the inside the here and I'm running to get the query. Let me get the query. So this is not invalid. That query is gone. Let me take here. So we will get the query like this. So using the query plan, we can get the query as well. And we can give this query to application to team to troubleshoot. But how can we terminate? The terminate like I want to resolve the I want to resolve the CPU. So that means we need to terminate, right? So that is the reason go for SP who is active. From there, we can get the session ID and host name. And apart from that, like we can get the like how many times this query is executed and these things use this query to troubleshoot. So now the thing is like our now we are able to identify the queries which are taking iCPU. So using the activity monitor, using the performance dashboard, using the uh, top worker threads, we identify the queries. So where we can kill or wait based upon the thing. Most of the times, what we can do, we can based upon the application team will wait or terminate. So the thing is like now most of the CPU is resolved, but now the thing is like we need to understand why these queries are taking high CPU. What is the problem? So from there we need to start troubleshoot. The thing is like using the query plan or maybe activity monitor will get the query rate. So in that query, what are the tables are involving? Okay. So why that particular? So we need to go to that particular table and we need to check what are the tables indexes using, and those indexes having proper fragmentation is happening, like a rebuild is happening, a reorganization is happening, and we need to identify. So the thing is like from the DBA perspective, the first thing is like if you see any bad queries or something from the DB perspective, once we get the query, then we need to go to that particular table and we need to check that fragmentation, like index. What is the index fragmentation and what is the what I meant to say? Come on, a rebuild is there happen or not? So that is a we need to check. So if you remembered last week, we discussed one key area, SP bleach index. So like the thing is like here, I have a table, I have a query. In that query, my query, two tables are using that particular query. So I want to get the index metrics for those tables, right? So if you having the SP bleach index, then run the SP bleach index, so that will provide the our index recommendation and how many times index are using and what are like if you have any missing indexes that will recommended. So the thing is like once we run the SP bleach index for those tables, then collect the information and then go for manually check the utilization, then go this information given to the application team. So SP bleach index sometimes that will give the a kind of a index missing index information. But the thing is like if they're giving missing index information directly, don't give the index recommendation. Let me note down why, because here all our thing is like we are going for the post investigation for the CPU high. So what I mentioned, check the tables which are involving ICP. So once we get the table information, what we can do, go to the particular tables and collect those particular particular table index information. If we get the index information, what we can do in that indexes, what is the fragmentation, and we need to collect. So if we go for the spill bitch index, okay, if the my fragmentation is high, my fragmentation is high, so what will happen? That definitely the spill bitch index, it will give the some missing index information. Okay. Why? Because my fragmentation is more and I have some empty pages and my data is shuffling here and there. So for that, our query plan, it will give one more index to catch up that particular row identifier. So that is a reason if we have the more fragmentation on the tables, so that our query plan, it will recommend the covering index or maybe non this kind of a, it will give the non-cluster index information, it will recommended to create. So if you have any kind of a fragmentation is less. If you're not going for any rebuild, that time if you see any missing index, then definitely give the recommendation. So what I mean to say here, before giving the index recommendation to the application team or any other team, the first thing is our side, that particular table, do you have any indexes or not? Okay, if you have indexes, that's good. But what are the fragmentation? Those indexes. So we need to identify the fragmentation percentage. Fragmentation percentage. The fragmentation percentage is more high. That means because of the rebuild operations are not working as expected. Then because of this fragmentation, the queries are taking longer time. So now don't immediately run the rebuild reorganizations. You can tell them, okay, I'm going to rebuild or reorganize for this in table because of the use modifications update. The fragmentation happened uh, frequently, even though if you are running the rebuild reorganizations on the weekend, but we should occur on the Wednesday or Thursday because of the more fragmentation. I need to rebuild the indexes in the non-business hours. So the thing is like, as I mentioned, if you go for rebuild and reorganizations, before that, collect the before collect the before collect the SP glitch index and missing index information. Okay, missing information. So once we rebuild the indexes, then run the SP glitch index. That time, 80 to 90% those missing index will be gone. Okay, but if you rebuild reorganize also, if you see missing index, then you can recommend it to create the missing index based upon the reads the query is going to utilize. Okay, so the thing is like here, the fragmentation is high, then we can go for recommend. But the thing is like here, my fragmentation is not much high. But even though what are the tables are involving, those tables are taking more CPU. So then definitely we need to look for the our query execution plan. So we will get the query execution plan from the our activity monitor, or maybe who is activated, we'll get the query, right? So check the query execution plan, and using the execution plan, which module or which operator taking more CPU, like a cost. So we have to give the information to application team. They may check from their end, but DB team also, we need to generate a query execution plan, and we need to check which particular module is taking more cost. We can give the recommendation to them so that they can check instead of like why they're using star to collect the going for the table scan. Do we need to use any filter condition instead of going for the star? And are they using any distinct column in the right joints? So like that, we need to identify and we need to inform them. So fragmentations and the blockings always help the ICPU. And if you're having any bad queries, kind of like a joints and a star, if you see kind of a scenario, that because of the bad queries, CPU will go high. So this is a kind of a, our investigation. The thing is like, as I mentioned, first collect the information, then go for investigation. So what I mean to say, apart from that, what I need to check. Yeah. So
అది ఛార్జింగ్ అయిపోతుంది మీ దాంట్లోనే.
charging అయిపోతుందా? Oh, 1 minute. 1 minute. 1 minute. Good. Thank you. Thank you. Where I kept 1 minute. Thank you, Venkat. So where are we? Yeah. So this is the kind of our current CPU investigation. Okay. This is the uh, current system having CPU pressure. This is the live troubleshoot to collect the CPU information and queries, and from where we need to investigate. So, as I mentioned, we need to understand the index concept, and we need to understand the blocking concept, and we need to understand the who is active concept. So, if you know the this concept, our finding the CPU and giving the recommendation is very easy. So this is the kind of a current CPU system troubleshoot. So now let me stop the recording. Then we'll go for the another scenario. Every time that particular time the queries are giving the problem. Okay, giving the CPU alert. Let me stop the recording. We'll go for other things. Stop recording.